Good morning. This is Vaishnavi Dwivedi on behalf of my team P2 under the guidance of Dr. Manish Gupta is here to represent our seminar topic, that is image forgery detection using CNN. Other members include Sonali Saxena, Alvina Aslam and Ankita Saxena. Here we begin. Now this is the index or the list of contents that we have followed. Next is the introduction. Now the first question arises is what is image forgery? So basically tampering an image or making any changes onto an authentic image is image forgery, or that image will be called as a forged image. And now as many apps provides you with this facility of manipulating images so easily, it has become difficult to differentiate the two. So here's what our project is all about, to tell whether the image provided is real or fake. In technical terms, authentic or tampered. Now this is the example of image forgery, how a part of an image is being copied and pasted onto the same image. So this is how forgery works. Next is the motivation. Now as tampering of an image is becoming challenging day by day, it is being used for hiding fact evidences. So, not only this lose the reliability of an image, but also being used as a tool for doing certain unlawful activities. So, our project helps to detect the duplicated region using DCT, that is discrete cosine transform, and then is followed by CNN, that is convolutional neural network. Our basic aim lies in developing an efficient system. Now there are two ways, as you can see. One is an active approach, which is simply digital watermarking, like easily we can detect seeing the watermark or whether the image is forged or not. Another one is a passive approach, which is quite tough, like it is followed by tampering, which is of three types: image splicing, image retouching and copy move. Image splicing is simply copying and pasting onto the different image, like copying a part of one image and pasting it onto the other. Image retouching is just altering the image, and copy move is copying an image, a part of an image, and pasting it onto the same image. The process of creating fake image has been tremendously simple because there are so many apps that do free or at a very low cost like Adobe Photoshop, GIMP and Corel Paint Shop and many more. So there are many cases of digital image forgery. Now copy move forgery. What is copy move forgery? As we have discussed, copy move forgery is copying a part of an image and pasting it onto the same image. Now, as the copied part originated from the same image, its essential parts such as noise, color, texture do not change, and this makes certain problems. This is an example how a part of an image is again copied and pasted onto the same image. Techniques that can be used to detect image forgery. So, first of all, input digital image. As you can see in the flowchart, first of all, you have to input the digital image, then dividing into the overlapping blocks. Third step will be a feature extraction to extract certain features out of the image. Fourth is lexicographical sorting. Then locate the forged region and detect the result. Techniques used in our project. The project deals with the detection of copy move forgery using DCT, that is followed by the CNN. Now at the initial stage, first of all, we'll transform the input image to the grayscale. Why grayscale? Basically to reduce the certain parameters. Then will be the DCT. Once the filter image are integrated, then we'll train using good and forged images, and then the simulation values depict the better performance. For the copy move images, CNN classify accuracy of 95.83% on training data and 88.63% on test data. Next is Why we have used DCT over other approaches? So the answer is very simple, because DCT detects forgery better for JPEG images. Now module wise description, the modular description of our project, like module 1 is taking image as input and converting into the grayscale. So first of all, we'll take as input an image which we want to test whether it is forged or not, and then we'll convert it into grayscale. Second module will be implementation of DCT. DCT we are using just to separate images into parts of differing importance. Module third will be zigzag scan. Zigzag scan is used to differentiate or to separate the higher energy coefficients with the lower energy coefficients. Now, as the higher energy coefficient will appear first and then the lower coefficients will appear afterwards. Fourth module will be quantization, that is to convert the continuous range of values into the finite range. Module 5 is implementation of lexicographic ordering. Basically, it's in organizing your data into a very sequential way. Then Euclidean is applied to determine the similarity of vectors. Seventh will be calculation of direction of vectors. Eighth, determination of accuracy, and ninth one is the implementation of CNN. This is the whole flowchart showing implementation of algorithm as explained. Now, copy move forgery detection. For CMFT, two conditions are imposed. The blocks are non-intersecting and non-overlapping, and the similarity index doesn't exceed a threshold. Now moving on to our next slide, that is the basic overview of the approach. So what we had done is simply we had divided our image into certain blocks. Then we have extracted the features from the blocks. After extracting those features, we have made the feature vector, and those feature vectors are lexicographically sorted, and the blocks belonging to the same region are matched. Then in order to obtain higher success rate, instead of marking the areas belonging to the matched block pairs, the center of the matched block pairs are computed. And these are regarded as the reference points belonging to both the copied and the pasted image. Now DCT as followed by CNN. So this is the architecture of CNN that we are doing in our project. So the steps in CNN is, first of all, you need to initialize your CNN, followed by convolution. Third is max pooling. Why are we using max pooling? Is to basically reduce the dimensionalities. Then we have fourth is flattening. Flattening is converting data into the 1D array. So we have done it as to create a single long feature vector. Fourth is full connection. Then every node in first layer is connected to every node in the second layer, followed by loss function set, then the accuracy set, then train image data generator set, and test image data generator set. The optimizer that we have used after full connection is used to change certain attributes such as weights, learning rate, and to reduce the losses. Now the result and discussion. Experiment configuration, if you see, the experiment is run on a 64-bit dual-core machine with a processor speed of 1.99 GHz using 1 GB of DDR2 RAM. The research is done using Python since all of the algorithms are coded in Python. We coded an algorithm to randomly create a copy move attack on the images. Result analysis, like the size of an image, execution time has been shown. Then this is the output of DCT. Next will be initialization of CNN. Fit CNN into images, like initialize CNN done, convolutional done, max pooling done, flattening done, and this is how it works. Epochs running in backend. This is the screenshot we have attached. Then this is the accuracy plot. Conclusion. The work so far engaged to detect whether images have been generated from others. However, in a long term perspective, image dependencies and the analysis of the mutation of their semantic content across these dependencies might be useful. In a similar way, we can envision extensive forensics activity on social networks or video databases. Thank you.